Saturn's moon Enceladus has fascinated scientists for decades. I mean, it's one of the shiniest objects in the solar system thanks to its ice-covered surface, and scientists love shiny objects, just like all the rest of us. Geysers and its south pole launch water and organic molecules from its global subsurface ocean into Saturn's beautiful ring system. Now, a paper in the journal Nature Astronomy claims that there are spots on the surface with an awful lot of heat coming from the ocean below. And if Earth is any guide, that's a pretty good starter pack for life. In the paper, an international group of researchers looked at measurements that the Cassini probe's radar instrument made back in 2011. Radar usually shines microwaves on something and then learns about its surface features based on how the microwaves bounce back. But Cassini's radar instrument is designed so that if you turn the transmitter off, it can still detect light given off by the surface itself. And that can tell you about its temperature, like how seeing a metal glowing red tells you that it's hot. As it flew over Enceladus' south pole, Cassini measured a stripy pattern of temperature changes near the pole right next to a bunch of fractures in the surface. Scientists have thought for a while that Enceladus' ice might be broken up into big sections that act like icy versions of Earth's tectonic plates, and these stripy temperature measurements seem to confirm that idea. Most of Enceladus' heat comes from tidal effects, where Enceladus gets stretched and flexed by Saturn's gravity as it orbits. Thin ice flexes and heats more than thick ice, and it also lets more underground heat through to the surface. So higher surface temperatures probably mean thinner ice, and plates with different thicknesses would make patterns of warmer and cooler areas on the surface, just like Cassini measured. Icy plates would also make something like volcanoes and faults that we see on Earth's plate boundaries, again, just like the geysers and fractures Cassini saw a few years ago. So between the higher temperatures and the active geysers, the ice near the South Pole could be way thinner than we used to think. Based on the evidence they collected before this, astronomers estimated that the ice on Enceladus might be 30 or 40 kilometers thick in some places, and maybe 5 kilometers thick at the South Pole. But now it seems like ice right near the pole might be as little as 2 kilometers thick. This makes the South Pole a prime target if we ever want to send something to check out the oceans under the ice. And we might actually do that because heat bubbling up from the bottom of a huge salty ocean of liquid water and organic molecules sounds a lot like the conditions where life first evolved here on Earth. If there's life anywhere else in our solar system, Enceladus is one of the best places to look for it. Meanwhile, other researchers are looking into how our entire universe came to be in the first place. In a recent video over on SciShow, we talked about 5 big mysteries that poke holes in our understanding of the universe. But if a recent paper in the Astrophysical Journal has anything to say about it, that number could drop down to 4. A few minutes after the Big Bang, the universe was filled with a hot plasma of particles that sometimes fused together to form the first few elements on the periodic table. So hydrogen fused into helium, and then helium combined into different types of lithium and beryllium. And our current model of this process does a great job of predicting how much of each element was produced, except lithium-7, a type of lithium with 4 neutrons. There was about a third as much lithium-7 in the early universe as the model predicts, and there's no accepted explanation for why. But the authors of the paper are proposing a pretty simple way around this frustrating problem. Cosmologists generally assume that plasma throughout the early universe acted like what's called an ideal gas. Ideal gases are in equilibrium. They look pretty much the same everywhere. And assuming the plasma stayed in equilibrium leads to those great predictions of the amounts of elements, besides for lithium-7. But by the time lithium was forming, that plasma was really quickly cooling down to where new elements couldn't fuse together anymore. And as the authors point out, there aren't great reasons to assume this happened at the same time everywhere. So the plasma might not have been in equilibrium as it cooled. By changing that one assumption, the researchers were able to create a model that predicts the right amount of every early element, including lithium. If they're right, it's a beautifully simple way to explain a problem that had a lot of physicists thinking we needed whole new laws of physics. But of course, we'll have to wait and see if it gets accepted by the scientific community. The researchers don't really have strong reasons to think that plasma wouldn't be in equilibrium, they just say that it's plausible. And their model also doesn't predict anything new, it just matches what we already know, which makes it hard to test. We should just keep running the Big Bang over again, take some measurements, just, More Big Bangs! The authors end the paper by encouraging more research into this new model to see if it predicts anything else that we haven't seen yet about the universe's first few minutes. They also point out that the insides of stars might be out of equilibrium in a similar way, so research into those types of plasmas could lead to other predictions that scientists can go out and test. And if it does, maybe we will have an update to that list of mysteries about the universe sooner than we thought. Thank you for watching this episode of SciShow Space News. One of our favorite parts of space is the Earth. It's a really great planet, and April 22nd is Earth Day this year, and on Earth Day, the March for Science is taking place in Washington, D.C. and all over the U.S. To show our support for scientists and their work making the world a better place and understanding it better, we made these Knowledge is Power shirts and posters that we think are great for any day, but if you want one before April 22nd, make sure you order yours today. There's a link in the description, and if you want to keep getting smarter along with us, don't forget to go on to youtube.com/SciShowSpace and subscribe.